Let's try to understand what do we mean by convergence of sequences. Essentially, convergence, the word convergence should give you an intuition that it means that a convergent sequence is a sequence that is tending to some finite limit. So, whatever your sequence is, it is tending to a finite limit, and that's what convergence is. This limit should be finite. That is what is convergence. So, formally, let's define what do we mean by convergence. If you have a real number a, so let a be a real number, then we say that the sequence an converges to a, and we denote it as the following. You can write it, let me just change the color. You can probably write it an tends to a, or you can write it as that limit as n tends to infinity an equals to a. So, essentially it's the limit of the function an. Okay, it's the limit of the function denoted by an. And we say that if any neighborhood n epsilon, so epsilon neighborhood containing all the terms of the sequence starting with a certain rank. Now, what is neighborhood? If you remember, neighborhood means that if x belongs to the neighborhood of a, that would mean that the distance between x and a is less than epsilon. The distance between x and a is less than epsilon, or x minus a mod is less than epsilon. Okay, so that's what we mean by neighborhood. So what are we trying to say? We are trying to say is that if any neighborhood of a contains all the terms of the sequence starting with certain rank, okay, starting with certain ranks. This is a real line. If I have a here and all the terms of the sequence are somewhere here, this is n, epsilon neighborhood of a, then we call a is the limit of the sequence, or the sequence is converging to the limit. Okay, so the sequence is converging to the limit. So essentially, if there exists an a belonging to real number r such that an tends to a, we say that the sequence an is convergent. Okay, and we call this number a. A is the limit of the sequence. A is the limit of the sequence, and if there does not exist any such a, if there does not exist any such a real number a such that any a such that an tends towards a, we say that the sequence an is divergent. We call this sequence a as divergent. So essentially, a sequence will always be in one and only one of the following situation. There can be two situations for any sequence, two situations for any sequence. And what will that be? That will be either convergent or divergent, either convergent or divergent. A sequence can be either convergent or divergent. Convergent means that it has a finite limit. Divergent means that either it has no limit or an infinite limit. Now, the examples that we took when I was trying to tell you what a sequence means, then the first sequence that we took was 1 by n. Okay, 1 by n. So we saw that the sequence will be 1, 1 by 2, 1 by 3, 1 by 4, getting minute and minute. So what will happen as n tends to infinity? As n tends to infinity, okay, you will have terms which are getting closer to 0, and 0 is a finite limit, and 0 is a finite limit. Okay, so we will see whether this function is convergent or divergent in some other video, but just ponder upon it. Is this what is happening? Whether this sequence is moving towards 0 or not. And also I want you to ponder upon another thing. I want you to ponder on the odd number sequence. So we had 2n plus 1. Okay, so starting with 3, 5, 7, so on and so forth, and moving on and on and on. Moving on and on and on. And putting all natural numbers, what will happen to this sequence? Will this be moving towards infinity, because there are infinite number of natural numbers, right? Or not? I want you to ponder upon these two facts.